In this lecture of business mathematics, S2 business mathematics for CA and corporation, we are doing some of the practical problems in our text, page number 2.28. So this question is to evaluate this particular determinant. Now, there are many ways to evaluate this particular determinant. Let's see how we can do this with respect to the properties of determinant. So, I'm going to solve this particular determinant by using the properties of determinant. Properties of determinant. By applying the properties of determinant, let's see how we can solve this question. So let's consider the first as the row. Let's consider the first one as the row 1 and this as the row 2 and this as row 3. Okay, when you add the row 1 with the row 2, you'll get the first element as 0 and the rest of them will be 2b, 2c. And what about R3? When you are adding this particular row with other rows, it will be 0, 0 and 0. So let's apply this equation. So I'm going to change my R2 by adding R2 with R1, as well as R3 will be changed to R3 plus R1. Okay, now let's see what is happening. So the first row there won't be any change, so it will be A, B and C. The second row will be having 0, 2B, 2C. The next it will be 0, 0, 2C. So the advantage of making 0 is that we are reducing the operation. You don't have to find the second term as well as the third term if these things comes as 0. So let's see, it will be A into 2B, 2C minus 0 into 2C. So minus B into, it will be 0. Then minus plus C into, it is 0. So only thing is you need to evaluate this expression only. So that is 4ABC. So we got the answer as 4ABC. So by adding these two rows, what happens is you get the 0 in this side, and whenever the zeros are coming, you don't have to find the determinant of particular thing, and you are reducing the number of steps. This is the advantage of using the property rule of determinant. Then let's see another question. So another question is, you are asked to show that means you are asked to prove the LH is equal to RHS. Okay, so you need to find the determinant of a 4x4 matrix, and that value should be A, B, C, D. This is your task. So let's name these particular row. So let it be R1, this R2, and this one R3, and this R4. So I'm going to use the same principle as before. I'm going to add this R1 to R2, R3 and R4. So the operation will be R2 is equal to R2 plus R1 and R3 is equal to R3 plus R1. R4 will be equal to R4 plus R1. So let's see how it goes. So A, B, C and D. So the first term will be 0, 2B, 2C, 2D. The other will be 0, 0, 2C, 2D. Next it will be 0, 0, 0, 2D. So this is a 4x4 matrix. Now it is almost similar to our 3x3 matrix. The only thing is you need to take A. So what happens is you are considering this particular element. So cover this particular column as well as the row. You get the sub matrix, right? Let's write the sub matrix. So the sub matrix will be 2b, 2c, 2d, 0, 2c, 2d, 0, 0, 2d. Now, rest will be as similar as others. So, minus b, because this is positive, this is negative, positive, negative. This is how it goes. So, then what is the next thing? You need to cover this element containing b as the column and the row. So, we get another submatrix. So, that will be 0, 2c, 2d, 0, 2c, 2d, then 0, 0, 2d. Okay, then we have plus c into. So, using another highlighter, cover this particular column containing c and the row. So, we'll get the answer as 0, 2b, 2d, 0, 0, 2d, 0, 0, 2d. Okay, now minus d into, take another highlighter. Let this be covering this column and the particular row. We'll get a submatrix, and that is 0, 2b, 2c, 0, 0, 2c, 0, 0, 0. Okay, so now according to the properties of the determinant, whenever we are having a column containing 0, here also we have a column containing 0, here a column containing 0, as well as a row containing 0. In such cases, this determinant will be equal to 0. The determinant of this thing will be equal to 0, and determinant of this thing will be equal to 0. So, only thing you need to find is the determinant value of this. So, a into, you take out the b. So, the b, it will be covering this column and the row, cross multiplying 2c and 2d minus 0 into 2d. So, we'll get 8, 2 into 2, 4, 4 into 2, 8. So, 8, A, B, C and D. So, this is the answer. Okay. Now, the next question is, you need to find the adjoint of the particular matrix. So, in order to find that adjoint, what is the first thing you have to do is find the cofactors. So, in order to find the cofactors, A11 is equal to minus 1 raised to 2. 1 plus 1 is equal to 2. Now, it will be 4 minus 3. We will get it as 1. A12 is equal to minus 1 raised to 3. Then 6 minus 3, that is equal to minus 3. Now A13 is equal to minus minus 1 raised to 4. Cover this column and the row. It will be 3 minus 2. We'll get it as 1. Then A21 is equal to minus 1 raised to 3. Covering this column and the row, it will be 4 minus 1. So, minus of 3. Now, A22 is equal to minus 1 raised to 4. Covering this column and the row, it will be 2 minus 1 is equal to 1. A23 is equal to minus 1 raised to 5. Cover this column and the row, you will get it as 1 minus 2. This column and this row, 1 minus 2. 1 minus 2, we will get it as minus 1. So, minus of minus 1. Now A31 is equal to minus 1 raised to 4. Minus 1 raised to 4 is 6 minus 2. So it is 4. A32 is equal to minus 1 raised to 5. Minus 1 raised to 5, it is 3 minus 3, that is 0. Then A33 is equal to minus 1 raised to 6. Covering this column and the row, it is 2 minus 6, that is minus 4. Now writing all the cofactors. We have 1 minus 3, 1, minus 3, 1, 1. We have 4, 0, minus 4. Now find the transpose of this to get the adjoint. So adjoint of A will be equal to 1 minus 3, 1, minus 3, 1, 1, 4, 0, minus 4. So this is the adjoint. Now the next question is, you need to find another adjoint of this matrix. So A11 is equal to minus 1 raised to 2, 2 minus 0, we'll get it as 2. A12 is equal to minus 1 raised to 3, that is covering this column and the row, it is 0, so put 0 as such. A13 is equal to minus 1 raised to 4, covering this column and the row, it will be 0, minus 4, and the answer is minus 4. Now A21 is equal to minus 1 raised to 3, covering the column and the row, it will be minus 1, minus 3. So minus of minus 4. A22 is equal to minus 1 raised to 4, that is equal to, covering this column and the row, 2 minus 6. 2 minus 6, that is minus 4. A23 is equal to minus 1 raised to 5. Cover this column and the row, we have 2 minus of minus, that is plus 2, so it is minus 4. A31 is equal to minus 1 raised to 4. Covering this column and the row, we get it as 0, minus 6, so minus 6. Now A32 is equal to minus 1 raised to 5. Cover this column and the row, we'll get it as 0, so 0. Now A33, that is minus 1 raised to 6. Cover this column and the row, we'll get 4 minus 0, that is 4. Okay, now let's write all the cofactors over here. So we have 2, 0, minus 4. We have 4, minus 4, minus 4, minus 6, 0, and 4. So let's find the transpose to get the adjoint of A. So adjoint of A is equal to 2, 0, minus 4, 4, minus 4, minus 4, minus 6, 0, 4. So this is how we find the adjoint of the matrix. Now let's consider another question which says you have to find the corresponding adjoint as well as the inverse. You are asked to find the adjoint as well as the inverse. So first thing you have to do is A inverse is equal to adjoint of A by determinant of A. So we need to find the determinant of A. So determinant of A is, so the determinant of A can be evaluated by 4 into 6 minus 2 minus 1 into 4 plus 1 plus 2 into minus 4 minus 3. So that is 4 into 4 minus 5 minus 14. That is 16 minus 19. So we'll get it as minus 3. So determinant of A is minus 3. Put that in a box so that you won't skip that particular step. Now, next thing you have to find is the cofactors. So let's find all the cofactors. So the cofactors A11. A11 is equal to minus 1 raised to 2 and 6 minus 2. That is equal to 4. A12 is equal to minus 1 raised to 3 minus 1 raised to 3. So you cover this particular column and the row. That will be 4 plus 1. Okay, so you'll get it as minus 5 over here. Then A13 is equal to minus 1 raised to 4. Then you cover this column and the row. It will be minus 4 minus 3. So you get it as minus 7. Then A21 is equal to minus 1 raised to 3. So cover the column, the row, you'll get it as 2 plus 4. So 2 plus 4 is equal to 6. So minus of 6. Then A22 is equal to minus 1 raised to 4. So you will be covering this row and the column. So it will be 8 minus 2. So we get it as 6. 8 minus 2, that is 6. Then A23 is equal to minus 1 raised to 5. Cover this row and the column. So it is minus 8 minus 1. So it's minus 9. So minus of minus 9. Now A31 is equal to minus 1 raised to 4. Okay, minus 1 raised to 4. So cover this column and the row. So we'll get it as minus 1 minus 6. So it will be minus 7. Now A32 is equal to minus 1 raised to 5. Okay, so cover this column and the row. It will be minus 4 minus 4. So minus of minus 8. A33 is equal to minus 1 raised to 6. 4 minus 3, 4 into 3 is 12, minus 2, 10, so it is 10. Okay, now write all the elements now. So we'll get a 4, minus 5, minus 7. We have minus 6, 6 and a 9. Then minus 7, 8 and a 10. Now let's take the transpose so that we'll get the adjoint of A. So the adjoint of A will be 4 minus 5 minus 7 minus 6, 6, 9 minus 7, 8 and 10. Okay, so this is the adjoint and this is the determinant. So let's find A inverse. So A inverse is equal to adjoint of 4 minus 6 minus 7 minus 5, 6 and 8. Then we have minus 7, 9 and 10 multiply by 1 by 3. So 1 by 3. The determinant is divided. So 1 by 3 into 4 minus 6 minus 7 minus 5 minus 6 minus 5 6 8 minus 7 9 10 is the answer. Now one more question. It says to us, it asks you to find the inverse of that particular matrix. So inverse of that particular matrix is, so in order to find the inverse, first thing you have to write is adjoint of A by determinant of A. So let's find the determinant. So determinant is equal to, so the determinant value will be equal to 2 into 4 minus 2 minus 1 into 4 minus 1 plus 2 into 4 minus 2. So it will be equal to 2 into 2 minus 1 into 3 plus 2 into 2. That is 4 minus 3 plus 4 will give you an answer 5. So determinant of A is equal to 5. Put that in box. Now let's find the cofactors. So in order to find the adjoint of A, we have to get the cofactors. So A11 is equal to minus 1 raised to 2. That is 4 minus 2. We'll get it as 2. A12 is equal to minus 1 raised to 3. Then 4 minus 1. That is minus of 3. Then A13 is equal to minus 1 raised to 4. Cover this column. That will be 4 minus 2. So that is 2. Now we have A21. That is minus 1 raised to cube. Cover the column. Row 2 minus 4. 2 minus 4. That is minus of minus 2. A22 is equal to minus 1 raised to 4. Cover this column and the row 4 minus 2. That is 2. And A23 minus 1 raised to 5. So cover this column and the row 4 minus 1. So 4 minus 1 is 3. So minus of 3. Then we have A31, that is minus 1 raised to 4. Cover this column and the row. We'll get it as 1 minus 4. That is minus 3. Now A32, minus 1 raised to 5. Cover this column and the row. 2 minus 4. 2 minus 4. That is minus of minus 2. Then we have A33. That is minus 1 raised to 6 and 4 minus 2. So we'll get it as 2. Now let's write all the cofactors. So we got 2 minus 3, 2. We got 2 minus 3. A21 is 2, then again it is 2 again. So 2, then minus 3, then minus 3, 2, 2. Okay, now let's find the transpose to get the adjoint of A. So that is 2 minus 3, 2, 2, 2 minus 3, minus 3, 2, 2. So this is the adjoint. Now A inverse is equal to 1 by 5 into, write all the adjoint, that is 2, 2, minus 3, 2, 2, 2, minus 3 and 2. So this is how you need to find the A inverse. Hope this is clear for you, and if you have any doubt, please let me know. Thank you.